Now in this lecture we will start our journey to object-oriented programming in Java by introducing you about class, state and behavior. So this is important concept to learn in object-oriented programming. So now we will talk about a class. So what is class? Class is a blueprint of an object. By hearing that you will be thinking what is blueprint everything. Blueprint means the whatever the documentation or whatever it is required for building an object that will be defined inside a class. So for example, an object is a you want to create an object of vehicle. So the vehicle will have certain features like as car name, car type, car color, everything will be there. So these things will be the constructs which we need to learn about vehicle. So these things will be we will create a vehicle class and have fields and methods on that vehicle class. By doing that, we will be able to emulate the object-oriented concept. Now let us talk about the other things of a class. So class is if it doesn't have any physical memory allocated. It is just a representation of blueprint of an object, and so it will not acquire any memory. When we create an object of class, that object will acquire the memory. Next thing which you'll need to discuss is the class name syntax. So class name should follow the upper camel case notation, which means the name should start with a capital letter, and if any new words comes, then that word should be also be capitalized. Next, we will discuss about state. So state means variables which we declared inside a class. So if a class is there, we have to have some variables to hold the particular state of the class. When you create an object, that object will have some state. So that object state will be holded in these variables. So the variable can be either primitive or derived data type. So it can derived data type means yeah, we are explained already in the derived data type section. It means it is we are user defined data type. In that case, will have a variable which will hold the reference to that particular memory location. So that's how the state will work. Now let us see the other features of state. So for example, for state is like if a car is there, if a vehicle is there, then the number of tires can be considered to be a state of it, so that we can initialize it using variables and then we can manipulate it. Next thing which we need to discuss is variable names as the state name syntax. So variables names have some syntax which is lower camel case. So we have to follow the lower camel case notation in order to create in when we create variables and all. So next we will discuss about behavior. So behavior means methods in Java. So what are methods? Methods we already seen that we have created some methods under the class. We have created some methods. These methods will have behave like behavior. For example, if there is a bird will have some properties such as color and its wings. Everything is there. So the another property which you need to learn about behaviors means. For example, for a bird, it is ability to fly. So fly will be a behavior for a bird. So like that, for an each object, there will be some specific task which it can perform, or certain functionality it can perform. These functionalities are called as behavior, and behaviors are considered to be methods in Java. So we'll write a specific methods for a particular class, and then we will handle the behaviors. So now we need to discuss about is the types of return types we can provide to methods. So methods usually can have primitive or derived data types as their return type, and some cases, and in case of if the method is not returning anything, we have to keep the method return type as void. It is compulsory to have a return type something specified for a particular method. And next thing is the naming convention for methods. So methods follows lower camel case notation. So method name should be start with small letters and will have capital letters if any names any new word will come. So that's it for the behavior and state and class. Now let us see the practical for this. Now let us discuss about a simple program based on class, state and behavior. Here we can see a vehicle class I am created. So the vehicle class has properties such as color, number of tires, everything it has, and it has two methods: start and break. So these methods are the behaviors, and the other things are the state. So this is how we create a class structure in blueprint of an object, or the blue class structure. So using this class, we will be able to create a object-oriented object in Java. Now let us see the program for the main method of this program, where I am calling this class. So in the main method, I am creating vehicle object is the vehicle object I am creating. So this is an object, vehicle object I am creating. After creating the vehicle object, I am putting some values into them, and initializing the name and color of that object. Number of tires I am initializing, and after that I am calling the start and break methods respectively. By that I am able to invoke the, you can see how we need to invoke the state. So states are invoked by the dot and dot, the function dot and the method name. Like that I am invoking. So let us run this program to see the output. Here you can see the method, whatever we has written inside the methods of break and start and break, that has appeared. So that's how the state and behavior. Now let us see another program. Now let us see a simple program based on class, state and behavior. Here I am creating a book object. In the book object I have three states: name of the book, author, and number of pages. These are the three states, and I will have a behavior which is the method to print the all the details about the book. So we can access these fields or the state using the behavior. So in this lecture, I am focusing on how to access the fields. Here we can see I am using just simply plussing that variables, and we are able to. I am using appending it into the system.out.println, and I am printing it out. So this is how the state class object is look like. Now let us see the main method to see how they are invoked. So here in the main method, I am creating an object for each book. Three books I am created, and for each book I am initializing the variables, and finally I will call the book details to get the book details of the particular books. So this is how the simple code of is explaining the class, state and behavior. Now let us see the output for this program. Here we can see the output has came. So each book's details are being printed. That's it for this program, and we will summarize this lecture. So here in this lecture we have seen the various class, state and behavior, the various object oriented constructs. So here it's important to understand that the way class is very important to understand. We will handle we have to use class everywhere in Java. So each class will have state and behavior. That is the most important thing about a class. So we have to understand about more object oriented principles will be explained in the next lecture. Thank you for watching. Hi and welcome back. And in this section, we are going to discuss about static and non-static members. So we are seen in some of the programs we are declaring variables using the static keywords. So in this lesson, we are going to discuss about the static and non-static members in a class. So first thing which we need to understand about static is that static members are part of the class and not the instance of the class. So by meaning it is that the static members, whenever you have static members, that means that members are belonging to the class rather than the instance of the class. So when you create an instance of the class, also you can access the static members, but the static members belongs to the particular class. So next thing which you need to understand is how we will declare static members. We use the static keyword followed by that particular, if it is a method name. If it is a variable, then the variable data type. Like that we will declare the static members. And next thing which we need to understand about static is static members can be accessed using class names. So we can use the class name to access the static members, even though it is in we can access static members using the objects also. That means instance of the class also we can access the static members. But when you do that, the compiler will throw a warning for that, that you are accessing the non static member in a non-static way. Like that, it will warning it will provide. So you try to use the static members using the class name, using their class name. So in the next, we will discuss about non-static members. So non-static members are part of the instance of the class. So when we create an object, and that time we can access the non-static members. So they will be part of the non-static part, and they should be declared as in the scope of the class. So if we declare a variable without any static or any keyword, without static keyword, then that variable will be non-static. So that variable can be accessed through creating an object of the class, and using the dot operator you can access the particular variable. So that is it, the theoretical aspects of static and non-static members. Now let us see some programs to understand the concept. Now let us see a program which has static and non-static members. So in this program you can see have variables, which is a school variable is declared, that is a static constant, that's why it is all caps. And next thing it is I am declaring a count variable, which is a static variable. And after that I am declaring an id variable, which is non-static. And I am created three methods in this class. First one is to register the student. So in this register student method, the students will be registered, message will be printed. Along with that, the count of the student count will be also incremented. And next thing is the call student method. This method will simply print a message to the message like hello message will be printed. And the next one is method is the status method, in which the status of the for a particular student school will be printed. So this is a simple program, logic of the student object. So student object has these kind of members. Now let us see the main method to see how it is accessed. So in the main method of this program, I am created a student object and given its name and id. And I'm using the register method to register the student. And then I'm calling the student using the call student. And after that I did for the two students, I created two student objects. And at the last I will use this call the static method status by using the student class name. So whenever we are calling a static member, we have to use the class name. And if it is a non-static member, you are seeing we have to create a object first, and then we have to use that object dot the main name of the non-static member non-static method. Then we have to call like that. Now let us see the output to show how this is working. Here you can see total student count came, and this is the program. Now let us see another program. Now let us see another program to explain about static and non-static members. So here I am created a class, bird class. In that bird class, I have created a static variable number of legs, and following that name and color to non-static variables I have created, and following that two non-static methods, fly and make noise. So these methods will simply print the message into the console. So that is the bird object. Now let us see the main method for this program. So here in the main method, I have created two objects, crow object and eagle object. So these two objects has been initialized properly with some values, color and other properties I have initialized. And after that I am calling the fly and make noise methods respectively. So this will, you can see how the static members not non-static members are accessed and called. And finally, one more thing to say is we can access the static field like number of legs using the object notation or dot. Like that, if we use also we can access the non-static way also you can access it, but the compiler will show it is in a yellow color, throwing a warning like you are using it in a non-static way. You should use in a static way by meaning it that you have to use the class name to use the particular static field. So we learned in this section about, let us run this program first. Here we run the program. So the both the fly method and the make noise method of respective classes are getting called. And finally, this is how the last statement is printing the access to the particular number of legs field it is coming. So in this section, we are discussed about the static and non-static members. So we are seen about them, how we will declare the non-static members and static members, how we access the non-static and static members. We have seen in this lecture. So continue watching the series. Good luck. Hello and welcome back with another lecture on objects in Java. So what is objects? It's a one of the fundamental thing in object-oriented programming to understand what is object. So objects are instances of the classes. So if you have a class and you want to create something based on that class, you need to have objects. So you will create objects from classes. Class is but a blueprint, but object is the instance of the class. So that is how the definition for object. So how we will use objects is whenever we want to have a implementation of the class or we want to use the class, and that time we need an object. Objects are created to access the non-static members also, and objects are used everywhere in the program. Now let us discuss about the other things about objects. So how we, whichever way we can create objects is objects can be created by using when we are doing deserialization, by using cloning and other methods. But in this most of the session part, we will use an operator called as new operator, and that is the most common way of creating objects using the new operator. And the syntax for creating an object is object name, the name of the class, followed by the reference variable name equals to and the new operator, and followed by the constructor of the object. So constructor means how we want to construct our object. We will describe about constructor in our next lecture about constructors. For now you think like it's a way to call the particular object. So that is about the introduction to objects in Java. Now let us see some programs based on this. Now let us discuss about a simple program based on objects in Java. So I have created an object symbol class, employee class I have created. So this employee class has two fields, ID and name. Now let us see the main method. So here in the main method, I am creating an object. Here you can see the how we are created object. Previously also we have created many objects. So the syntax is the same. Employee name, the variable name, the reference variable name, followed by the new operator and the constructor for the particular object for a class. So like that, the object is created, and after creating the object, I am setting the particular values, and you can see on the on the next line we have the I have used the instance of operator. Instance of operator can be used to check the reference variable is belonging to the instance of a particular class or not. So this can be coming handy if you want to check for a particular object reference is belonging to a particular class. And let us see the output for this program. Here you can see the output, the message of it's an instance of a particular class, and the output and each employee name and ID is printed. That's it for this program. Now let us see another program. Now let us discuss about a simple program based on an object. So here we will create a class first, a class of a car, and in that car class we will have several fields to hold the particular values, and then we have a method, car details method, to return you the print the particular values of the fields. Now let us see the main method. So in the main method we can see I have created two car objects, and in the car objects I am initializing some values. You can see the both the values are same, but if we check for a condition, then it will return you a false statement. So what will happen is, if you create a new using new operator, whenever you create an object, a new object will be created in the heap memory of the system, and this memory location reference will be given to the particular reference variable. And if the both the reference variables are pointing to the same objects or the same memory location, at that time only the equality operator will work fine, and it will return you a true value. So for the third object, it is referring to the same as the first object. So at that time what happens, the return value will be true. The equality value will be true. Now let us see the output to understand more. Here you can see the output. The car details method is printing all the details of the car, and you can see how the equality operator is working. To check, it will work only if both the references are pointing to the same memory location. So that's it for this lecture on objects. In this lecture, we learned about objects, how we can create objects, and how they are used in program. And in this lecture, we also seen some simple programs on object creation and object, how we can compare objects also we seen. Now let us continue watching the series. Thank you for watching. Hello friends and welcome back. And in this lecture we are going to discuss about object-oriented principle called as constructors. So in this, constructors are used to construct an object, which means that if you have an object and you want to initialize an object with some values, and you want to do some operations of on an object before the object is been sent to the before the object is been created, that time we want to write some logic. That logic can be written in the constructors of the program. So a constructor can be created by using the class name followed by the function brackets and the block, break a bracket and the block. So here you can see there is a the constructor syntax is similar to method, but the difference in constructor is that the constructor will not return anything. Eventually it will return an instance of an object, but in the code we will not return anything. And the next thing which you need to understand about constructor is the two different types of constructors which are available. The first one is the default constructor. For example, if you are not providing any constructor in your class, there will be a default constructor which is provided by the compiler, so that when we create an object, we will be able to successfully create the object. So you will already seen the usage of constructor in object creation. So object creation time, we will call the constructor to create the object using new operator. And next thing which you need to discuss is the parameterized constructors. So parameterized constructors means constructors can have arguments also. So if a big class is there, and if a class is there and it has some several fields, so for each fields you can initialize them by passing the parameter as them as parameters. So to do that you have to declare a parameterized constructor, but be careful with declaring a new parameterized constructor. It will break the old code. If you remove when if you create a parameterized constructor, then the default constructor will not be available, and you have to always use the parameterized constructor. So if an old code where they are using the default constructor, that code will break. So to avoid that, you have to have a default constructor as well as a parameterized constructor in your code if it is required to have a parameterized constructor. So this is it for the theoretical aspects of constructors. Now let us see some practical programs. Now let us see a simple program based on object called a student object I'm creating. And first I will create a student class, and to see the constructor, how we will create constructors, everything in this section we will in this program we will cover. So let us see the program. Now here created two fields, ID and name, and branch, and now following that I have created three different constructors. The first one is the non parameterized constructor, or non default to default constructor where there is no parameter, and second type is the parameterized one, with the id being the one parameter, and third one is taking all the three fields into the as its parameters. This is how we can initialize. We can see the how I am initializing in the parameters constructors. We can use the particular variable, the field with to initialize the with it with the parameter which is applied. So that's how we will initialize a constructor, initialize an object using constructor. Now let us see the main method to see how the program is getting invoked. So here in the main method of the program, I assemble one program, and in this program I am just I created three student objects I am creating. First one with calling the default constructor, where they are just I am put only a system.out.println message, and next I am calling the id constructor with only one parameter, and then finally I will call the constructor with the three parameters. So that's how we will call the constructors while creating an object. Now let us see the output for this. Here you can see the default constructor is invoked, then the single parameter constructor is invoked. Finally, the all parameter constructor with all the parameters has been called. That's it for this program. We will see with another program. Now let us see another program based on constructors. So how this the use case of constructor we can see in this example. So I have created an employee object. I have declared some fields. Also a static member I have declared. You can see, and in this example I am trying to access the static member using the constructor. I have declared a constructor here, and using the constructor I am trying to access the static members. You can access the static members successfully, and also you can invoke the other methods, non-static methods also you can invoke within the constructor. The constructor is looks like a method only, but the only the difference is that it will not return anything, and the constructor name should be same as the class name. Now let us see the main method to know how we are invoking this program. So here in the main method I am creating an object, and you can see in the first line I am creating an employee object and passing in the parameters. And the second line you can see I'm trying to create an object using the default constructor, but it is not possible because whenever you create a parameterized constructor, the default constructor will go, and this is why you have to be careful while using the parameterized constructor. So whenever you introduce a parameterized constructor, the old code we have to check whether anywhere the default constructor is being used, and if it is used, then we have to provide a default constructor in the class so that there will be no code breaking. So this is a solution for that. Now let us see the output to see how the values is getting printed. So here you can see the values are getting printed. The print method is getting invoked, and that's it for this section on this lecture on constructors. So here we learned about constructors, how we can create a constructor, how these variables values are getting initialized in the constructor, and how constructor can access static members also, and how we are seen about all about the constructors. So thank you for watching this lecture. Please continue watching the series. Hello friends and welcome back. In this lecture we are going to discuss about IAB and SAB. So this is important to know about this feature in Java which allows to have instance initialization block which is called as IAB. So the purpose of IAB is to initialize objects. So we already seen constructors can do the initialization of object, but IABs are used to initialize all the constructors. If you have multiple constructors, you can have an IAB in which you can initialize all of the code for the constructors. So we will see when the practical for this section will come. At that time, you will be able to fully understand how the IAB is working. For theoretical aspects, and let us discuss more. And here we can see one more thing about IAB is IABs are invoked before the constructors. So whenever there is a constructor, then the IAB will be invoked first, then the constructor will be invoked. So during object creation part, we have to remember that. Then next thing is the syntax of IAB. So IAB will be declared in the class body, and in the class body we will have the IAB. The syntax is like a braces followed by the whatever the statements we want to execute in the initialization block. So that's it for IAB. Now let us see SAB. SAB means static initialization block. So this is a block in which we will initialize our static members. So static members we already seen that are class based members. So that belongs to the class. So static members has to be initialized in some context. So in that case we will use SABs. One thing about need to know about SABs is SABs are invoked when the classes are loaded into the memory. So we don't need to create an object or construct an object in order to invoke SABs, whereas IABs are invoked when we create an object, and SABs are invoked when the class is loaded into the memory. So now let us see the syntax for SAB. So SAB syntax is like the static keyword followed by the braces in which we want to initialize our static members. So this is it for the theoretical aspects regarding the IAB and SAB. Now let us see the practical for this section. Now let us see a program based on IABs in Java. So IAB, instance initialization block are used to initialize particular instances, and when we create an object, we can initialize those objects using the IAB block. So here I have created a new object which is student object, and the student object I have created three fields: ID, name, and branch. And I'm using the initialization block to print the message and initialize the variables. Here you can see in this part I am initializing the variables, and after that I am declaring the constructors for for this class, and the constructors are default constructor, parameter is no are constructor I will declare, a parameter is constructor also I will declare. So that's how here we can see here in this code this is how we will declare an initialization or instance initialization block. Now let us see the main method for this program. So in the main method of this program, we will be calling the student object, creating a student object here, and I can see when the student object is created, and the constructor will be invoked, and before the constructor is invoked, the IABs will initialize the variables. So IABs will be calling before the constructor, and it will execute the initialization part correctly, so that If any if we again, if you are trying to create an object, at that time also the IABs will execute. If there are multiple IABs in a program, then it will execute in a top down fashion. So if three IABs are there, then the first IAB, according to the from the top how it is positioned, that position it will execute. And we can have multiple IABs and constructors in a program to initialize an object. Now let us see the output for this program. Here you can see the IAB block is printing before each constructor is getting invoked. So it is initializing the variables. When we print the variables, it is printing the initialized code. And this is how we will use IABs. We will come with another program. Now let us see a program for SABs in Java. So static initialization block we had explained. Now let us see a program for that. So here in this program I have created a employee object. Employee has ID and salary and a static field of minimum salary. So I am initializing the minimum salary field in the static initialization block. Here you can see the syntax for static initialization block. Static followed by the braces. In that we will write the code to initialize the variable, and after that I am created a constructor. In the constructor it's a parameterized constructor, and in the constructor I am initializing the salary to the minimum salary. Like that we can do, and this is a use case of static initialization block. And finally in the main method I will have create an object for this employee, and I will initialize the values using the constructor. And let us see the output of this program. Here you can see the output as screen. The static initialization block is called. So if static initialization blocks are important to understand, they are called when we create when we load the class into the memory. So we don't need to even create an object in order to load the particular static initialization block. They are loaded when the class is loaded into the memory. So we have to think about that. Now let us see another program. Now let us see a simple program to explain both static initialization block as well as instance initialization block. In this program, you will have multiple SABs and IABs, so that you will be able to grasp the concept fully in this program. So here we can see I have created a vehicle class. In the vehicle class, I have created two fields, color and name, and after that I have a static field also here. And after that I am using a static initialization block to initialize the static variable. And after that I am put another static initialization block and instance initialization block. So you can see this program. Please take time to see this program how I am written the code. And in this code I'm just using this multiple SABs and IABs, so that our variables will be initialized in a certain way. So IABs and SABs can be used together. The thing to remember about SABs is SABs will be loaded only once a class loading happens. At that time the SABs will be loaded into the memory. So only once it will create into the memory. And to understand about it like that. And the next thing which you need to understand about SABs is, if there are multiple SABs, then it will execute in a top to bottom fashion. So the first SAB which is in the first line will execute first. Like that it will work. The next thing which you need to understand is, if SABs and IABs are grouped together, SABs will execute first, then IABs, and then the constructors will execute. So that is the order of execution of these blocks. Now let us see the output. And before output, you will see to the go to the main method. I have created two vehicle objects, and I am using the constructor to initialize the objects. So let us see the output for this program. So here you can see initially static initialization blocks are called, Then later IAB's instance initialization blocks are called, and after that the constructor is getting invoked. So for the second case, second object when I create, at that time the static blocks are not called because the static members are only called per class loading. Once the class is loaded into the memory, only once in the program, so only once it will execute. That's it for this session on lecture on static initialization block and instance initialization block. So in this lecture, we are learned about how we can use these blocks to initialize variables inside our code. Without we already have constructor to initialize, but static initialization blocks and instance initialization blocks are used to, for example, static initialization blocks are used to initialize if there is a database connection and you want to initialize the only once per loading class loading you want to initialize a string or something. At that time you will use the static initialization block, and instance initialization block is used whenever if for common code for constructors, if there are multiple constructors and you want to initialize all the constructors at once, at that time we can write this logic of instance initialization block, and and this is how this part. And thank you for watching. Please continue watching the series. Hello friends and welcome back to the lecture. And in this lecture we are going to discuss about association and composition, which is an important part to learning object oriented concept. So let us start. Association in Java. So what is association? Association is the relationship by which one or two classes can be linked together. So how the relationship is like, the relationship is called as a hash relationship. So an object is belongs to another object, like that relationship will be. So how we will achieve association in Java is by using a reference variable of a particular class in another class. We can use like that to create the association relationship. It can be either one to one, many to many, or one to many relationship. So it can be achieved if there is, in case of many to many relationship, we will use data structures such as array list or arrays to hold the particular values, reference values. We will see in the practical to understand more. Now let us discuss about the types of association in Java. So there is two types mainly, as is a relationship and has a relationship. So is a means inheritance. Inheritance will be covered in another lecture. For now, it is thing like inheritance is a relationship in which the both classes will be tied like in a parent-child relationship. Now, next thing which we need to discuss is the hazard type association. So, hazard type association is classified into two: aggregation and composition. So, aggregation means there is a the both the entities are independent of each other, which means if you delete an object, that doesn't affect the other object. So the both the life cycle of the objects will not be dependent. For example, if there is a car and a music player, if you remove the car, the music player will work still. Similar to that, a a car and its battery. So if you remove a toy car and a battery, so if you remove the batteries from the car, the battery will work still. The it will not affect the working of the batteries. So that is how the logic is of aggregation. Whereas composition is much more weaker form of relationship in which the both the relationships are dependent on each other. So what happens is when you delete an object, the other object will be affected and it will be also removed. So for example, a room and a house. So if you remove all the rooms from if you remove a house, then all the rooms in the house will also be removed. So that kind of relationship is called as composition. Now let us discuss more about composition. So composition is a relationship in which can be used we can implement composition by using by creating a reference variable of a particular class in another class. By using that relationship can be achieved, and in some case, most of the cases, composition is favored over inheritance, and it will allows us to have multiple inheritance also. So we will discuss about that when the inheritance lesson will come. Now let us see some of the programs for this association and composition. Now let us see a program for association in Java. So association relationship has a relationship or a belongs to relationship. So in this relationship is implemented by the help of creating a array list or an array inside the particular class which we want to create. So now here in this example we are going to see a relationship between person and its laptops. So person will can have multiple laptops. So the multiple laptops we will have a reference where here you can see the person class. Inside the person class, I have declared an array list to hold the laptops. So the laptop, it is a type, it will hold the laptop types. We will discuss about array list when the collection lesson will come. For now, think like it is a data structure which will hold the all the list of particular laptops. So that's it for the person class. Let us see the laptop class how it is implemented. So in the laptop class, I am declaring the name of the laptop and other thing, and I am using a constructor to set the name. And let us see the main method to see how we are invoking these methods, these classes. So let us see the program. Here you can see in the main method, I have created objects for the particular laptops, and I'm created a new array list, and in that array list I'm adding each one by one each laptop, and finally I am setting the laptop into the while using the constructor for the person class. I will be initializing the laptops. So like that I am initializing the laptop, and finally using an enhanced for loop I am printing out all the laptops that is belonging to the person. Now let us see the output for this program. Here you can see laptops of David is printed. So like this association relationship can be implemented. Let us see another program in which we will discuss about composition. Now let us see a program to show the composition in Java. So composition is a strong, it's a relationship in which if you delete the both the objects life cycle are depend upon each other. So if it doesn't, one cannot exist without the other. That is the relationship. Now let us see the program. The program will be about a car and car showroom. So the relationship between a car showroom will have multiple cars. That is a relationship. If the car showroom is not there, then the cars will not also be not there. So that is the relationship. Now let us see the program to implement it. So here is a car object. The car object has several fields to hold the car name, color, everything. And after that, I am declaring a car showroom. So in the car showroom, I will have the name of the car list of cars will be there in that car showroom. So you can see that I'm using an array list to hold the reference of the particular objects. So composition like association also is implemented by using like this relationship. Only the it is a relationship difference is that it cannot exist. The both the life cycle of the objects are depend upon each other. That is the difference. Now let us see there is a method also to print the details of each car. Now let us go to the main method. So in the main method I am creating a different cars, and I am initializing it with using the constructor, and after that uh, I am creating an array list and putting each car into an array list, and finally the car showroom object will be created here, and using the array list to set the particular constructor. Now let us see the output for this program. Here you can see each car details has been printed. So this is it for the lecture on association and composition. So we have learned about the relationship, has a relationship or belongs to a relationship in Java. This is a complex lesson. It will be difficult to understand in sometimes. These relationships are not like standardized or anything, but we have to understand the relationship between these classes can be achieved using this creating the reference variable in a list or array we can create. Thank you for watching. Welcome back, friends. In this lecture, we will discuss about Java's pass-by value. So, what is pass-by value by meaning? So, pass-by value means that if there is a variable and we are passing that variable to a function and modifying that value function or a method if you are modifying the variable value in the method and whether it will affect the variable or initial variable or not. That is the meaning of pass-by value. So let us discuss about it. So Java is strictly follows pass by value. So what happens is when you create a new function and you will pass the value as as a variable as a parameter to the function. At that time the copy of the variable is provided to each function, each method, sorry. And we will confuse mainly method and function. In Java everything we will call as methods. In other languages it is called as functions. And in methods we will take the parameters and the copy of the object will be supplied to the methods, so it will not modify the actual data. That is how the pass by value works. In some languages it will be passed by reference. And now let us discuss about the if for each cases such as string and derived data type, primitive data type, and arrays. We will discuss in the program to understand more about the pass by value concept in Java. Now let us see a program for explaining pass by value in Java. So this is the example one program. So in the example one program, I have created the main method. And main method in before main method, I have created three methods to do the pass by value operation. So in pass by value, what we will do is we will have a parameter to the each method, and in the parameter we will change the modify the parameter value and then check whether what is happening to the particular method before and after. So that is the logic. So you can see here in the main method for each derived data type as well as primitive data type, I am created a primitive data type of employee, and for that I'm setting a name, and then after that in that method I will set back the name, and finally I will print out the messages, print out the value whether it is changed or not. So that is the logic. For string also I'll do the same. Now let us see the output to understand how the pass-by value is working for each derived data type, primitive data type, and the string. So here you can see the output as came. So here you can see for derived primitive data type, it is the value is the same. For derived data type, it is changed. That means there what happens is the pass by value only it is happening for derived primitive data type as well as for derived data type. In case of derived data type, what the value which is copied is like the reference to the particular memory location. So that value will be getting copied and the new reference variable will be created pointing to the same memory location. So at that time pass by value will happen, but since the both the variables are pointing to the same memory location, if you change the value it will affect the initial variable also. So that's how in case of derived data type it is working. Next case is string. So in case of string, what is happening is a string is a uh, immutable data type. So which means that when you change the value of string, it will not change the and value in that is the logic of the string. We will explain about string when the class about strings will come. So now you think like string is a immutable data type, so we cannot change the value of string once it is declared. Now let us see another program. Now let us see the another program on pass by value. In this case, we will take an array and check whether array how it is working, pass by value or pass by reference, which one will work. And in case of arrays, you have noticed that we are used some cases of this pro in this section. In this programming lecture, we are using the arrays, and in arrays will be declared like this in the main method you can see. And I am initializing the value with 5. In this is only a single element array, and in the function of change, that in that method I will change the array value to 10. That's how that logic is. And before and after I am printing out the array value. Let us see the output. So here we can see the output, the value is modified. This reason is because the pass by value only is happening in case of array also, but this value is pointing to the same memory location. Even though the value passed by reference, the reference value will be copied to the new method, but this value is still pointing to the same memory location. So when you modify it, the value will be getting modified. That's how the pass by value feature is working in case of arrays. Now let us wind up this session. So in this lecture we are focused on pass by value feature on Java, and we have seen the example for strings, and derived data type, primitive data type, as well as for arrays how it is working. And thank you for watching. Please continue watching the series. Now, in this final lecture of this section, we will discuss about variable arguments. So, variable arguments was introduced in JDK version 5. So, it is a feature which allows variable number of parameters to a particular method. So, if you have a method in which we will denote a variable argument parameter as a dot dot dot, three dots followed by the parameter name. So, that parameter will be considered to be as a variable argument parameter, and it will we can handle the variable type variable argument parameter by using an how we handle an array. Like that we can handle the variable argument parameter, so that there will be no issues. This is a requirement which was laterly introduced, so which is very helpful. If we don't need to have parameter, for example, if we need to have a function with like 10 parameters, 10 parameters everything, that can be reduced to have a variable argument parameter. So to avoid the length of parameter method parameters, also we can use the variable argument parameter. And then one more thing about variable argument parameter is we can have only one per method. And another thing about is it is if there is multiple parameters or including the variable argument parameter in a method, then the variable argument parameter should be declared the last, so that the compiler will be able to fetch it correctly. And let us discuss about some programs based on variable arguments. Now let us see a program for variable arguments in Java. So here I declared a method, sum method. In the sum method, I am taking a parameter which is variable argument. So here you can see followed by the int. I have declared three dots to denote the variable argument, and so the name of the variable argument is param. And in the method, what I'm doing, how I am accessing it is how I access an array. The same way I can access the particular value of param value. So like that I'm accessing, and finally you can see how I'm adding the numbers to together to return the sum of the numbers param values. That is the logic of this program. And in the main method I am calling the sum method with a different set of parameters. First I will not call have any parameter, then I will have one parameter, then two parameter and three parameter, like that. So this will explain how the no, how the parameter will work, the variable argument parameter, how it is working. Let us see the output for this. So here you can see all the sum values is calculating for the all the method calls, and this is how variable argument is working. Now let us see another example on variable arguments. Now let us discuss a program on variable arguments which has multiple arguments. In this method, you can see in this method print. This method has uh, two parameters. The last parameter is a variable argument parameter. So here we are accessing the variable argument parameter like an array and printing out the values. And here I am doing the system.out.println so that the people will be able to understand the output. And next thing which we need to in the main method I am calling this method with a different set of parameters, so to know whether how the variable argument parameter is working. Now let us see the output for this. So here you can see the output as came. So the values are getting appended to the single line. That is how the logic of that flow of the program. So let us wind up this section, this lecture, by summarizing it. So here in this lecture we are going through the variable argument parameter concept in Java. So it allows us to have variable length parameters, and this is a very good feature. So in methods where we are not sure with how much parameter it will come, we can declare a variable argument parameter and then use it to use an array concept to iterate the variable arguments. That's it for this lecture. Thank you for watching.